Okay, so let's review what we were talking about yesterday with identifying associations. If we're talking about the number of days to be alive and the number of days until your death, what kind of correlation do you think that's going to be?
Negative.
All right. Well, let's see. If I'm counting up the days to be alive, if say today I've been alive for 500 days, tomorrow I will be alive for how many days?
500.
501. So my days alive, I'm going up. But the days until I die, I'm counting down. They're decreasing. Because every day that passes, I'm one day closer to dying, right? So my arrows are going in opposite directions. So that is a negative correlation. Okay, a negative correlation. This is stuff from yesterday, yeah. Yesterday's classwork that you could do the self-check. But we're going to go and explain it today. All right, so number 2, the day of the month and the wind speed. Why? Right, it is no correlation because the day of the month has nothing to do with how fast that wind blows. They do not correlate or they do not associate. This is what you did yesterday if you did in your notebook. All right, number 3, the age of a car and its selling price. Okay, well, let's think. In general, if I buy a car that is older, so that means its age is increasing, right? It's an older car. What's going to happen to the price? It's cheaper. It's going to drop. Not classic. We're just saying in general, overall. Not like vintage or classic cars or anything. Just in general, if you go to a car dealership, if the age is older, if the age goes up, the price usually goes down. What correlation is that? Negative. My arrows are moving in opposite directions. Negative correlation. What about this? The weight of a vehicle and its gas mileage. Okay, well, what happens about the weight? If I take the weight of a car and I'm getting a bigger car, the weight increases. The gas is going to go by faster, so that means my gas mileage, how many miles per gallon I get, is going to go down. So again, what kind of arrows do we have? Negative. When we're doing this, is it easier for you to see the correlation when I draw the arrows? Yes. So if you were doing this as a test strategy, wouldn't it be good to try to draw the arrows yourself to see that correlation? Yes. So it is negative. All right, what about this one? The outside temperature and the number of people in attendance at the beach. Well, what happens if my temperature drops? Less people are going to be there. So is that a positive correlation? Yes. Same thing. What if my temperature goes up? More people. Still a positive correlation. Positive. What happens to one? The same thing happens to the other. Temperature goes up, people go up. Temperature goes down, people go down. All right, the month of the year and the number of birthdays. No correlation, you're right. When you're born is just random. It's just based on when you're born. It doesn't matter. Your birthday isn't determined by your month you're born in, right? Your birthday, like how many people were born in February isn't because it's the month of February. It's just because it's how many people were born. It's random. So there is no correlation. All right, the next one. The population of states, but that's still random, and the number of senators in the state. But you're not going to say that many in February, that many in March. It's not a guarantee.
You lazy kid.
Ooh, did you hear? He's absolutely right. Now, this one was a tricky one. Excuse me. It's getting a little loud. This one was tricky because you have to know how many senators each state has. Every state has 2 senators. It's not like their House of Representatives that depends on your population. So because every state has 2 senators, does it matter if you're a big state or a little state? No, so there is no correlation. No correlation. All right, what about this one? In general, the weight of a child and his or her height in inches.
Actually, a little bit. Oh, wait, no.
So the taller you are you going to weigh more or less? Typically more. Think about, now we're just talking in general with kids. Think about Mueller. I go grab some students from every grade level at Mueller. Kindergarten, first, second, third. What's going to happen with a 5th grader compared to a kindergartner? They're going to be taller, right? Are they also going to weigh more? Yeah. So I said in general, what happens? They grow. So it is a positive correlation.
Isn't it association too?
So, all right, so we said that typically as your height increases, the weight also increases. You get bigger. So there is a positive correlation. Now, let me ask you this, just in general, for adults, would adults still have a positive correlation? No, because typically once you're an adult, you're already at your height. So it's not increasing or decreasing, but the weights could be all over the place. So if you were to if you were to go to the mall and ask 100 people that were 5'6" how much they weigh, your graph would probably just be random. No correlation in adults. Yes.
When I think of this, because when I think of this, I think like the weight of a person and the height in inches. Maybe the weight part throws me off because when you're an adult, sometimes because some people when you with your weight, it can make your height or something like that. You know
Right,
what I mean?
but adults. But remember, this question was about a child.
I know, this is weird.
Yeah, that's kind of a weird question. All right, and then the last example. The number of hours studied and a test score received. Right, if you study more, your grades are probably going to go up. In general, for most people, same thing. If you study less, your grade's probably going to go down. Same direction. What's happening to one, the same thing is happening to the second. So it is a positive correlation. Okay, so today we're going to learn how to actually construct the scatter plots. So if we look at this first example, Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. So we have all these players, it's shown in the table. Now it says, use the data in the table to make a scatter plot, then answer the questions. So how am I going to get all this information into a graph? Slowly? But what process would I use? In order to put things in a graph, what do I have to have?
X and Y.
X and Y. I have to have coordinates, ordered pairs, right? How can I make an ordered pair out of Jared's data?
You could put 14.
Hold on. Okay, 4. Hold on. 14Y and then 4.
Good.
As the X.
All right. So he used the graph to match it up. He knew the distance was going to be my X value. The baskets made is going to be my Y value. So that makes this row X and this row Y. You can also remember on graphs, X is always coming first, tables, X comes first and then Y. So I could turn that into an ordered pair. Just like if I needed to write, I could turn every one of these into an ordered pair. Right?
Right.
Now, I need to plot these. So we might have to use a little bit of estimation because on the bottom, on my x-axis, what is it counting by? Every line is counting by 2. Well, 4 for every other one. 4 is the numbers they labeled. But it's counting by 2s. All right, so let's plot Jared. I have to go over 14, up 4. Over 14, 14 is right here in between, and up 4. Jared's plotted. Let's plot Tyrell. Over 25, up 6. Well, 24 is there. The next line is 26. So where would 25 be?
In between.
In between. So 25, up 6, right about there. Can you plot the rest of them?
Yeah.
All right, I'm going to pause the video so we can plot. Okay, so now that we have our points plotted, we need to look at question number 1. What type of an association do you see?
I see.
This one's kind of tricky because we have this little group right here, we have this group right here, and then we have this guy here. But if I look at just a glance, or if I just kind of look in general, the closer you were to the basketball goal, the more baskets you made, right? When you moved further away, it went down, right? So I could kind of sketch a line like this way, right? I have this person out here that maybe they just really stink at making baskets. I don't know. But he's kind of like a loner, right? So when I look at this, what type of correlation does that look like now? That looks like a negative correlation. And then the question also says, what other observations do you see? Well, we already pointed out we have this loner guy, right? So one observation might be that one point is all alone. He doesn't match in with the rest of the graph. Anybody see anything else that's different about this correlation than other ones we've seen? The dots are what?
The dot is lonely.
It's lonely. Yeah, this one for sure is lonely. But I also notice right here, what's happening right here? There's nothing. It has a gap, doesn't it? So basically, if I look in this area around 20 feet, nobody was shooting baskets at 20 feet, were they? So the second thing that I kind of noticed is there's this gap in the data. Doesn't mean it's a bad thing in the data that has a gap. It just means nobody was shooting baskets from right there. Okay, so now that we have our scatter plot, let's use that data to answer A, B, and C. We're going to tell if the statement is true or false. So A, as the distance of the goal increases, that means I'm moving this way, getting further away from my basketball goal. As the distance increases, the number of baskets made decreases. Is that true or false? I'm moving away. What's happening to the baskets made? They're going down, right? The further away I get, they go down. So that is a true statement. What about as the distance of the goal decreases? That means I'm getting closer to the basketball goal. The number of baskets increases. So the closer I get, the more baskets I made. Is that true? Yes, that is also true. Further away, I make less baskets. Closer, I make more baskets. Well, what about C? As the distance of the goal decreases, so moving closer to the basketball goal, the number of baskets also goes down. That is false. That is false. So those are just some questions that you could be asked about a scatter plot. You would have to use reading the data to understand that. All right, let's look at the next two vocabulary terms. The first one is an outlier. A point that does not fit the overall pattern or trend of a scatter plot is known as an outlier. So if it doesn't fit the pattern, it is known as an outlier. So the next question says, was there an outlier? Did we have somebody that didn't fit the pattern? A loner? We sure did right here. Who was the outlier? So we have to look at what person did that point match up to?
14-4.
14-4, so that would be Jared. So Jared is our outlier. Jared is our outlier. He's the loner. He had a bad day. Couldn't make the baskets. Hope this wasn't basketball tryouts. Probably wouldn't make the team. That would be me because I can't shoot baskets. Yo, you think maybe he had a bad game? Maybe he had an injury. We don't know. I need more information before I can judge Jared. All right, let's look at the next vocabulary term, clustering. Clustering occurs in a scatter plot when there are distinct or separate groups of points. So if we look back up here, do we have any distinct groupings of points? Yeah, I have one right here, and I also see one right here. So in this scatter plot, I would say I have two clusters. Why do you think there was clustering in that scatter plot? It kind of looks like, to me, I would look at it and be like, okay, well, I must have had one group stand around this area and a second group stand around this area. Because I didn't have anybody standing in the middle, right? It looks like there were two separate groups of people standing at specific spots. So that could be a reason why we might have clustering. We don't know the reason exactly, but that just could be the reason. But we didn't have anybody even try to shoot a basket at 20 feet. But if they made 0, then I would have had a dot right down here on 0. But so I didn't have any dots. So they didn't answer. They didn't shoot. All right, let's turn it over to the back side. All right. The population of 10 cities and the number of elementary schools is shown in the table below. Make a scatter plot of the data. Now, we're not going to actually make the scatter plot, but I want to talk to you about it because I want you to notice some things because we're almost out of time. So, I want you to notice some things. Look at the population. Those are really big numbers, aren't they? But if I look at my graph, the population, those numbers on the x-axis are smaller because it says thousands. Look at your labels. So this number right here, 90, what does that really represent? 90,000. So if you were to plot these, you would plot them by the thousands. Okay?